All right, so now for these last two questions, we got, imagine that you're a carpenter building a floor of a rectangular room. What must the diagonal of the room measure if your floor is to be squared off properly? Given the dimensions of the floor are 12 feet by 15 feet, give your answer to the nearest inch. Okay, so if we draw a diagram, hit our rectangle. So we want 12 feet by 15 feet. Now, if we want this to be a true rectangle, we want all of our corners to be 90 degrees. And as a carpenter, if you check both diagonals, they should be the same length. So that's another way that they check to see if a rectangle is squared off properly. So, but in this case, we can just use the Pythagorean theorem to find the length of our last side, which in this case will be side C. So if we plug everything in, and we start breaking it down, so we're going to get 144 plus 225, which gives you 369. So if we take the square root of 369, we will get 19.209. Now that's going to be in feet, but the question wants it to the nearest inch. So we need to somehow convert this so that way we get the correct units. So the trick for this is just to simply multiply our 0.209 by 12 inches in a foot. So if we do that real quick, we can multiply. And it looks like we're going to get 2.5. Pretty darn close to 2.5 inches. So if you're a true carpenter, you would say 19 feet, 2.5 inches. So now the last question, we have an equilateral triangle with DE equals 60 inches. So that's this side over here, or units in this case. A is a foot at the foot of the perpendicular from D to CE, and B is a midpoint of DA. Find the length of CB. Now perpendicular just means it forms right angles, so that's why they have the right angle down here. So it's at the foot, and it's perpendicular, so it causes those right angles to happen. So that means we also have one on this side. So now, if we want to find the length of CB, which we can call X, we're going to have to find some lengths in here. Now, where do we start? Well, we know that it's equilateral, so all three sides have to be the same length. So that means that this is 60, and that this whole side is 60 as well. But what else do we know? It says midpoint, so that means it's going to cut it in half. So if we cut it in half, well, midpoint of DA, so this point here is the midpoint. So these two lengths have to be the same. We don't know what they are yet, but we're going to hopefully figure it out. So now, what can we do? Well, we also have this point here that's kind of right in the middle. And in fact, it will be in the middle. So we also know that this smaller length is 30. So if we look at the bigger triangle, we've got 60 here and 30 here, and our right angle is there. So if we double check, we got C should be 60, and so that means we're missing either A or B. Let's let it be B. So we have those three pieces there. So C squared is going to be 60 squared. And then we got 30 squared and B squared. So we got 3,600 equals 900 plus B squared. So if we isolate B squared, we get 2700. So B should be equal to the square root of 2700, which is approximately, I'm not 100% sure. I want to say it's like 52. I'm almost positive it's 52. Rounded. So we got B is 52. So now we can use this midpoint piece of information to find some more information. We have a smaller right triangle in here. So we don't know what x is. We know 30 is still in the bottom, but now because this whole length is 52 and the midpoint cuts it in half, we know that this piece has to be 26. So now we're missing the hypotenuse. So we can do it one more time. We'll use x instead of c. And we got our 30 squared plus 26 squared. So x squared should be 900 plus 26 squared, I believe, is 276, or excuse me, 676. So we're going to get 1576. And if we take the square root of that, it's going to be pretty close to 40. It's going to be a little under. I think it's like 39.7. I might be a little off, but it's pretty close to that. So that should be the length of CB. All right, so that wraps up section 9.3. Stay tuned for 9.4.